When a table represents a linear relationship, a linear equation can be used to represent the table. The linear equation will be of the form y equals mx plus b, where m is the rate of change and b is the start value. But it's also totally okay with me if you'd rather write y equals b plus mx. This form makes a lot of sense. Start value plus the rate of change, plus the rate of change, plus the rate of change. When you're looking at the table, you need to find the start value b. The start value is the value of y when x is 0. In this table, the start value is found in this row. It is the value of y 4 when x is 0. It's often the case that the start value is found in the first row of the table, but it's not always the case. So don't assume that the start value is found in the first row. Look for the row where x is 0. You'll find your start value there. The rate of change is how much y changes by when x goes up by 1. So what you're adding to y or subtracting from y repeatedly. In this table, x is going up by 1, up by 1. So I want to see what is happening to y as x goes up by 1. So as x goes from 0 to 1, what happens to y? Well, I subtract 2. As x goes from 1 to 2, what happens to y? Oh, I subtract 2 again. That means my rate of change is negative 2. Now, it better be the case that this rate of change is constant. If the rate of change is not constant, then the relationship is not linear, and you cannot write a linear equation. So my equation will be of the form y equals mx plus b, so I'm going to go ahead and write y equals negative 2x plus 4. But it is, again, totally fine with me. Oh, my 4's and my y's look the same. To write this as 4, y equals 4 minus 2x. Start with 4, subtract 2, subtract 2, subtract 2, subtract 2. Let us go ahead and practice. In this table, the start value is not found in the first row. The start value is found right here. This is the row where x equals 0. My start value, b, is 8, the value of y when x is 0. Now I'm looking at my table and making sure that x is going up by 1, x is going up by 1, x is going up by 1. So what's happening to y? As x goes up by 1, y goes up by 5. From 3 to 8, I add 5. From 8 to 13, I add 5. That means my rate of change is just 5. How much y increases or decreases by when x goes up by 1? My equation then is y equals 5x plus 8, which it's okay if you want to write that as y equals 8 plus 5x. Last example. Start value here is found in the first row. What is the value of y when x is 0? The start value is 4. What is the rate of change? Let's see what's happening to y as x goes up by 1. X is going up by 1, up by 1. Y is going down by 4, down by 4. That means my rate of change is negative 4. I can write my equation either as y equals 4 minus 4x or y equals negative 4x plus 4.